Yeah, Brad here with another quick video. Local friend of mine, collector, customer in this case, dropped off a Robotron board set. Dropped it on my porch actually. The MPU ROM board and I/O board is on the mounting plate and brought the soundboard separate. Apparently, uh, this game was converted to a switch mode power supply. So anyway, I dropped them off. I was going to do evaluation. Normally, I do a full repair restoration on the boards for most people. In this case, he bought the game. He's going to be selling it on. He says, "Hey, I've got a customer for this, and I really just want it." Make sure it's working 100% and make sure the stuff that normally tends to fail, ribbon cables, things like that, are gone through, so it's solid, but it's not going to be like show quality necessarily, right? So save a few bucks and get it back quicker that way. So that's what I did, and I'll go through, show you what I did on the bench here, and then we'll come back and look at some gameplay. So let me switch over to the bench cam here, and I'll show you the soundboard first. So here's the soundboard. Went through and put on a new 9-pin Molex header here where the power comes in. I did on all the boards that have power coming in. Tightened up all the screws on the 7805 here, the voltage regulator on the TDA 2002 audio amplifier. Removed and cleaned the legs on the ROM, on the 6808 MPU here, and then did a full test on the bench before I brought it over here. These are basically a whole standalone computer here. You can just simulate the inputs and test them. So that's real solid. ROM board over here, got a new 6-pin Molex header over here, and then new ribbon cable I make up here, all 3M parts, cleaned it up, rock solid. I did reflow the main headers here where you get the switch inputs and then the output that drive the soundboard. I/O board, new ribbon cable, straightened up a few bent pins, did a full test with splat, all 18 inputs, rock solid. The MPU here, went through battery holder was missing. I put on a CR2450 holder with a brand new CR2450. These have about 3 times capacity as a CR2032. Um, New Molex header here, 9-pin for power. And then the one thing, especially since we've got a switching power supply, is this Zener diode over here, ZR2. This monitors the 5-volt circuit, the input power coming in, and if it drops below what the value of the Zener is, it forces the CPU into reset. The original values on these boards, for some reason, is like 3.6, and once TTL gets below 4.7, things get goofy. And what happens on these with switch mode power supplies is and this also has a circuit that monitors the 12 volts. And normally on these games with the original linear, as soon as you shut power off, there's an unregulated 12 volt that comes in here through the header, and that one triggers the CPU into reset right away. But if you're running a switching power supply, then it stays up, and the 5 volt kind of drifts down to this original 3.6 volt, and then you start getting corruption in the CMOS RAM and things like that. So what I do is I change this out to a 4.7. So as soon as the voltage gets to 4.7, CPU's into reset, and then which disables all the traffic on the address and data bus, and also because of that shuts down the write enable for the CMOS RAM and protects all the data there. So anyway, and I also once I actually I removed and cleaned the decoder legs and the CPU legs. And when I powered it up, I did find 2 bad RAM chips on it, 416 DRAM. So I swapped those out. There's the bad RAM. This is the header from the MPU, header from ROM board, header from soundboard. There's the little 3.6 volt Zener. And then over here we have both of the ribbon cables from the ROM and I/O board. So let me set that back up and I will pull up the game and hopefully we'll get audio and video streaming. Okay, so here we are. I've got a little remote control on what you're seeing on the screen now is just some artifacts from when it was powered up last time. I have a remote control here on the bench, and I'll hit power on. We'll see our nice little carpet pattern, rug pattern. It's really a RAM test. There we go. So as you can see, it goes right into track mode. That tells me the battery's working, the CMOS is holding, retaining data, which is normally a volatile memory, but with the battery on, it becomes non-volatile. So On the bench, I also have a little PlayStation controller that I've wired up through a microprocessor, microcontroller, and so I'll coin it up here. Hit start. Might be a little loud. So I'm going to drop into the diagnostics here. ROM's good, no RAM errors. CMOS, no CMOS errors detected. We'll test some sounds. And then you have switch inputs here. Again, with the controller here, I can move the thumb sticks here. And we have left coin, player 1 start, got auto up, and then advance, which will take us to the RAM test. There's your grid lines for setting convergence on the monitor. A lot of people use the TPGs, the test pattern generators, which I do. You get solid red, solid green, solid blue, then color bars. Then we go into the bookkeeping data, and then game settings, configuration, and then back to a track mode. So again, this is good to go. It's been running on the bench for probably about 8 hours here. I did it earlier today, but I'm going to let it run overnight, and then I'll put it on the porch ready for pickup. So thanks for watching the video, and we'll see you guys back here on the next one.